All right, let's get right into it. There's this quiet but unbelievably powerful revolution happening right now. It's totally transforming our factories and industries from the inside out. And it's not just about, bigger machines or faster assembly lines. It's about making them smarter. And the real engine behind this massive shift, it's a concept called cyber physical systems. So here's our game plan. We're going to start with the big picture, this new industrial revolution. Then we'll dive into how these systems are the bridge between the physical and digital worlds. We'll even take a peek inside a modern smart factory, get real about the hurdles, and wrap up by looking at what the connected future holds for all of us. Okay, first things first, let's set the stage. What we're talking about here is a massive, fundamental change in how we make things. It is, quite literally, an industrial revolution for our generation. So I want you to forget that old school image of a factory, isolated machines clanking away with people doing repetitive manual tasks. The new model is way more like an intelligent ecosystem where every single part is connected, constantly talking to each other and always learning. It's a huge shift from being just a collection of parts to becoming a single integrated brain. And this whole movement, this entire transformation, actually has a name: Industry 4.0. The tech making it all happen, the absolute backbone of it all, is the cyber physical system, or CPS for short. They are the critical piece that makes this whole new industrial age even possible. So, what in the world is a cyber physical system, really? Let's zoom in a bit and figure out how these things actually work their magic. Okay, at its core, a CPS is this seamless blend of the physical world, the actual machinery on the factory floor, and the digital world of data and computing. It uses all this tech to watch, analyze, and control physical stuff in real time, making tiny adjustments on the fly without anyone having to lift a finger. A really good way to picture it is to think of a high-tech bridge. So on one side of the river, you've got the physical production floor with all its nuts and bolts. And on the other side, you've got this super powerful digital intelligence. The CPS is the bridge that connects them, allowing for this constant two-way conversation of information and action. And this bridge is always active, running on a continuous feedback loop. It's kind of like a four-step dance. First, it senses. Tiny little IoT sensors embedded right in the machinery are collecting a flood of data. We're talking temperature, speed, vibration, you name it. Second, it communicates, zipping that data instantly over a network. Third, it analyzes. Powerful computers crunch the numbers, looking for patterns or spotting a problem before it even happens. And finally, it acts. Based on that analysis, automated actuators make physical adjustments to the machinery. This whole loop just runs and runs, constantly optimizing everything. All right, so we've got the theory down, but what does a CPS actually look like in the real world? Let's step inside what they call a smart factory and check it out. The difference is pretty dramatic. A traditional factory is reactive. It fixes a machine after it breaks down. A smart factory, though, is predictive. It knows a part might fail next week and schedules maintenance ahead of time. Old factories were made of isolated silos. Smart factories are totally interconnected. And where old factories needed constant manual control, smart factories are becoming more and more autonomous. And the payoffs here are huge. You've got predictive maintenance, which, like I said, means fixing a machine before it breaks, saving a fortune in downtime. Then there's something called digital twins. These are perfect virtual copies of physical machines. You can run all sorts of crazy stress tests on the digital version without ever risking the real thing. You also get adaptive production, where the assembly line can pivot on a dime to make a custom product. And finally, integrated quality assurance, where sensors catch tiny defects instantly, making sure every product that leaves the factory is perfect. And the impact goes even deeper than that. Beyond just raw efficiency, these systems are great for sustainability, optimizing energy use right down to the individual machine. And here's a really crucial point. This isn't about replacing people. It's about enhancing our jobs, freeing us up from the boring, repetitive tasks so we can focus on higher value work, like creative problem solving, design, and innovation. And look, this isn't just some far-off theory. Check out this real-world example from Siemens. Their smart factory in Amberg, Germany, is basically a showcase for this tech. By monitoring thousands of data points every second, they've managed to achieve a production process with near zero defects. I mean, that's the power of CPS right there. And it's not just one factory. Entire industries are being completely reshaped by this. In the auto industry, it delivers the insane precision needed for today's cars. In pharmaceuticals, it guarantees the super strict quality control that regulators demand. And in the energy sector, it helps manage our complex power grids with incredible efficiency. Now, all this sounds amazing, right? But let's get real for a second. Adopting this kind of technology isn't as simple as just flipping a switch. There are some pretty significant hurdles to get over. So, on the technical side, trying to get a brand new smart sensor to talk to a 20-year-old piece of machinery, well, that's a huge challenge. That's the integration problem. Then there's interoperability, just making sure that devices from a bunch of different companies can all speak the same language. And of course, when everything is connected, data security becomes absolutely critically important. Then you've got the resource challenges. The upfront cost can be a huge barrier, especially for smaller businesses. There's also a serious shortage of people with the right skills to manage all this. Data scientists, IoT experts, cybersecurity pros. And you can't just install the system and walk away. You have to train your entire workforce on how to use it effectively. But even with those challenges, the momentum here is pretty much unstoppable. So what's next? Where is all this technology heading? Well, the next wave is going to be supercharged by a few key technologies. AI will make these systems even smarter and more predictive. 5G is going to provide the lightning-fast, zero-lag connection they need to communicate instantly. Advanced edge computing, which means processing data right there on the factory floor instead of sending it to the cloud, will allow for faster decisions. And those digital twins we talked about? They're going to become even more sophisticated, creating entire virtual factories for us to test and play with. And get this. Here's a really fascinating glimpse into the future. The rise of cyber-physical social systems. This is the next frontier. We're talking about systems that don't just understand machines, but also start to integrate data about human behavior and social context to make even smarter, more nuanced decisions. It's pretty wild to think about. So if there's one thing to take away, it's this. Cyber-physical systems are not science fiction anymore. They are here, right now, empowering manufacturers to build factories that are smarter, more flexible, and way more sustainable than we ever thought possible. This is the key to the next great wave of industrial innovation. And that really leaves us with a big, important question to chew on. As these machines get smarter and more autonomous, taking over tasks that people used to do, what does that mean for the future of human work? The conversation isn't about replacement, it's about evolution, and that's a conversation that all of us need to be a part of.